Hello, good morning and good evening everyone. My name is Priyanka Gharat, working as a VLSI Design Verification Engineer from Silicon Interfaces. Today I am here to present a basic concept of low power and area efficient 64-bit Vedic multiplier designed for high speed operation in ASIC DSP application. In the realm of advanced digital circuit design, power efficiency and area optimization plays a vital role in enabling the next generation of high-performance system. The research explores the fascinating world of Vedic multiplier, renowned by their remarkable speed and computational efficiency. A team of authors of this paper, namely Priyanka Gharat, myself, Darshan Sarode, Pooja Revnekar and Professor Purana Panda Shastri, who have done a significant contribution in proposing low power and area efficient 64-bit Vedic multiplier designed for high-speed operation in ASIC DSP application. You will note that each one of us have an extensive and deep experience in processor, computational, logic and low power. In the realm of advanced digital circuit design, where power consumption and computational efficiency are paramount, the conventional multipliers fall short. But fear not, for this there is a beacon of hope, that is Vedic multiplier. Imagine a multiplier that not only multiplies numbers but does so with a reduced power consumption, shorter computation time and a smaller area requirement. Yes, my friends, the Vedic multiplier is the answer for these challenges. Derived from the ancient art of Vedic mathematics, this multiplier presents an ideal choice for those seeking low power solution and enhanced performance in ASIC and DSP application. A quick word on explanation on the sutra in circuit. Sutra means thread, and traditional ancient sutra attempts to weave knowledge thread-like around and into their few simple words or syllables. You can consider sutra to be an algorithm to solve life issues. Vedic mathematics, known for their simplicity and efficiency, enables mental as well as manual computation with ease. The sutra algorithms within Vedic mathematics possess fewer operations and naturally exhibits inherent efficiency. With the power of Vedic mathematics, multiplying large 64-bit numbers becomes a breeze. Its simplicity of operation and approach makes applying the sutra a seamless experience. As the multiplier leverages fundamental element in numerous library components, the saving in power area and increase in the speed have a ripple effect across IPs, ASICs and DSPs. In this slide, we will be speaking more on the groundbreaking of 64 into 64-bit Vedic multiplier as in terms of speed, optimization and power efficiency, surpassing the capabilities of standard multipliers. A Vedic multiplier applies as bitwise multiplication within simultaneous product term, finding its column-wise addition. This is one of the best standard for the algorithm of fast multiplication. The main advantage of this Vedic multiplier is that we can calculate partial products and sums which must be fulfilled simultaneously. At the core of this remarkable innovation lies the sutra, that is Urdhva Triyabhyam, a profound algorithm discovered by the visionary scientist Bharati Krishna Tirtha, leveraging crosswise and vertical multiplication techniques. This algorithm empowers a Vedic multiplier with unparalleled advantages, that is low power consumption, reduced timings and optimized area, known as PTA. To validate our approach, we compare the design and PTA reports, demonstrating the inherent superiority of our architecture through comprehensive analysis and thorough experimentation. We showcase improved PTA metrics, reinforcing the tremendous potential of our innovative design. The block diagram shown in the right hand side of the slide shows working of the 64 into 64-bit Vedic multiplier, which is constructed using 32-bit Vedic multiplier alongside a ripple carry adder. The efficient architecture of the 64 into 64-bit Vedic multiplier, which enables rapid and optimized multiplication operation. The 32-bit Vedic multiplier takes in the respective portion of the 64-bit operands, performing the crosswise and vertical operations as multiplication steps as detected by the sutra, that is Urdhva Triyabhyam. The partial products obtained from this 32-bit Vedic multiplier are then fed into the ripple carry adder. This adder combines the partial products, taking care of the carry bits and ensuring an accurate summation to obtain the final 64 into 64-bit multiplication results. Through this strategic collaboration, we have achieved an optimized and highly efficient 64-bit Vedic multiplier. The intelligent integration of the 32-bit Vedic multiplier and the ripple carry adder showcases the power of architectural and the potential for enhanced computation in our design. The architecture of the Sutra employs a clever arrangement utilizing 4 32-bit Vedic multipliers. The output of the second and third serves as input to the 64-bit ripple carry adder. This adder performs the addition on the outputs and generates a sum. Resulting the sum is being taken carry forward from the previous step, which is being fed into the second adder, along with the top 32-bit for the fourth multiplier. The combination combines the generation of more refined output. To account for carry generation, the carries produced from the first and second adders are directed to an OR gate. The data from the first multiplier along the output of the OR gate and the lower 32 bits from the second adder are fed into the third ripple carry adder. By skillfully combining the outputs from each stage, the Sutra architects achieve 64-bit transparency. The architecture algorithm allows efficient multiplication with using 4 32-bit Vedic multiplier, enhancing the overall performance and the accuracy of the computation. Now, I would like to hand over the presentation to my colleague Darshan Sarode. He shall be explaining you the detailed process followed for the calculation of Vedic multiplier.
Thank you, Priyanka. Hello everyone, I am Darshan Sarode, a VLSI design engineer from Silicon Interfaces. In this slide, I will be explaining the multiplication process by following the steps mentioned in the Sutra. Urdhva Triyabdam Sutra is a general multiplication formula applicable in all cases of multiplication. It literally means vertical and crosswise multiplication. The line diagram which has been provided on the left hand corner of the diagram, we can refer that. It seems easy on the block diagram to talk in terms of 32 by 32 multiplication, but perhaps we should leverage the computer to do that. On my part, I will be explaining the simpler 4-bit numbers. Algorithm for Vedic multiplier using the Urdhva Triyabdam Sutra for two 4-bit binary numbers. For this process, here we have taken two 4-bit binary numbers A and B and as inputs and around 7 registers to save the outputs as K0 to K7 registers. Performing the following steps, we can get the multiplication of the A and B registers. In stage 1, we multiply A0 with B0 and store the results in the K0. Stage 2 multiplication of A0 with B1 and A1 with B0. Sum of the two results is saved into K1 registers. Stage 3, we multiply A0 with B2, B0 with A2 and A1 with B1. Addition of these three registers will be stored into K2 registers. Stage 4, multiplying A0 with B3, B0 with A3, B2 with A1 and A1 with B2, and addition of this is stored into the K4 register. And stage 6, multiplication of A3 with B2, A2 with B3, and some of the two results are getting stored into the K5 registers. And coming to the last stage, which is the 7th stage, we multiply A3 with B3 and the value are stored into the K6 registers. So save the results obtained in each stage ranging from K0 to K7 registers based on the index position, and all the K variables together considering their respective weights to obtain the products. It may seem somewhat like magic, but we have tried it and you can also try it and it actually works. The implementation of the 16 by 16 Vedic multiplier are used. Each 8-bit multiplier multiplies the corresponding bits of the input numbers. For instance, the first multiplier bits A7 down to 0 are multiplied with the B7 down to 0. Similarly, in the next multipliers, A15 down to 8 is multiplied with the B7 down to 0. B15 down to 8 is multiplied with the A7 down to 0 and the B15 down to 8 is multiplied with the A15 down to 8. The results of the first multiplication is considered as the partial product 7 down to 0. The second and third partial products are obtained by adding the results of the respective multiplication using an adder. To obtain the final 16-bit product, the remaining partial products 15 down to 8 from the first multiplication is added to the results of the first adder. This combined results is then forwarded to the third adder where the last multiplication values are added. Overall, this implementation of the 16 by 16-bit Vedic multiplier efficiently utilizes the 8-bit Vedic multipliers to perform the multiplication operation on corresponding bits to perform and uses the three adders to accumulate the partial products and generate the final product. based on the similar concepts can be extended to use for implementation the 64-bit Vedic multiplier as we saw earlier. The provided slide features the code used to implement a 32-bit Vedic multiplier based on the described logic. Additionally, this slide includes the example results for two input values and illustrates the functionality of the two multipliers. The code implements the Sutra algorithm to the letter and spirit and uses the features and advantages of the system Verilog language. We have been careful not to use any multiplication but use the AND logic bitwise. Next, we have dive into the intricate details of the 64-bit Vedic multiplier. Here you can observe the RTL gate level diagram meticulously synthesized using the Synthesis EDA tool. This diagram showcases the internal architecture of the multiplier, providing the glimpse into the intricate workings behind its exceptional performance. With the RTL representation, we can gain a deeper understanding of how a 64-bit Vedic multiplier achieves its impressive speed, area efficiency and low power consumption. Here we have a table that provides a comprehensive comparison of various multipliers. Let's explore each column one by one. Over here we perform a comparative analysis of three different types of multiplier or three different standard types of multiplier, which are booth encoded parallel multiplier, we have the modified booth encoded multiplier and the optimized Urdhva Triyambam Sutra based multiplier. This comparison highlights the gate count, area and power consumption of each multiplier. First, the result obtained, we can observe that the Vedic multiplier is around 3 to 4 times efficient in terms of gate count, around 3 to 4 times efficient in terms of area and around 3 times better in terms of the power consumption. Notably, the Vedic multiplier stands out with its superior optimization as it showcases reduced gate counts, efficient area utilization and the low power consumption. Thank you everyone.
Thank you Darshan for giving us brief explanation on evidence of the Vedic multiplier. This is Shastri Puranapanda, Senior VLS Engineer, Silicon Interfaces. As you can see, we explore wide-ranging applications of the Vedic multiplier. This multiplier finds the utility in various domains, especially enhanced performance and efficiency. Let us delve some of the applications of the multiplier. Here we are listing few application areas. Who doesn't need a multiplier? It is a basic ALU logic design for any CPU. So the benefit of power saving area is everyone's benefit. I should not fail to point out the cascaded effect of the saving could be exponential if recursive, especially however critical applications critical application would greatly benefit by an efficient multiplier. I shouldn't here it is help to some of the applications like digital signal processing, image processing, high performance computing, video processing, cryptography and communication. To conclude with three main aspects, as the novelty of the proposed architecture is the reduction of power, area, delay in the prefix computation stages in the power ground logic and bit addition logic that reduction the overall area delay product and power delay product. From the physical synthesis, it is clear that this proposed architecture is 3 times more efficient than next corresponding booth architecture. Adding to the Vedic multiplication is better compatible multiplier than existing multiplication in terms of lower power, smaller area and high speed. Let's summarize the architecture of the Vedic multiplier as a fewer steps and use of simpler components, resulting in less bill of materials and smaller footprints. The results in lower propagation delays, lower power, reduced area and timing than 64-bit existing multiplier. This algorithm is for the fundamental design and has potentials to disrupt current library usage as well as building blocks for ASICs and DSPs. It was a pleasure. Thanks for giving the opportunity to present applications, conclusion and summary of the Vedic multiplier. Thanks for all.